Good afternoon, ladies and gentlemen. My name is Kang, and my topic today is polymeric binder for transparent ceramic powder injection molding. Now, what is powder injection molding? It is actually the process which we form a molten powder feedstock into desired shape inside the mold via the application of heat and pressure. This technology is compatible with ceramic and metal powder, and it is widely considered an effective way of forming parts with complex geometry with high precision. Now, there are 4 steps for powder injection molding, which are mixing, molding, debinding, and sintering. The first step here is mixing. It is actually the process which we mix the transparent ceramic or metal powder together with the polymeric binder in order to achieve a feedstock. This feedstock, to make sure it's homogeneous, a twin screw extruder or a planetary mixer will be used. The second step here is actually molding. During this step, the feedstock will be poured inside the heated barrel, and after it melts, the screw inside the heated barrel would spin and generate enough pressure to force the molten feedstock out of the nozzle into the mold. When the mold opens, we will acquire the green part. The third step here is debinding. This is the step which we remove a portion of the polymeric binder from the green part and forms the brown part. Since some of the polymeric binder has been removed, this brown part is very fragile and must be handled with care. There are 2 types of debinding process, which are solvent debinding and turbo debinding. About which of these processes will be used depends on the composition of the polymeric binder. The final step here is sintering. During this step, the brown part will be heated at a very high temperature in order to burn away all of the remaining polymeric binder to acquire a drastically different final product. This final product is very different compared to the brown part. At this temperature, although it's very high, it is always lower than the melting temperature of the material powder. Since all of the polymeric binder has been removed, this final product is actually smaller than the green part, and the degree of shrinkage depends on the solid loading. Now, what is a polymeric binder system? It is actually a mixture of a lot of polymers. During solid state, it can stick and hold the material powder together, and in molten state, it can carry the powder around and act as a lubricant. The composition of the polymeric binder directly affects the viscosity and strength. The component of the polymeric binder system can be divided into primary binder, backbone polymer, and coupling agent. Depends on what kind of primary binder we use. The polymeric binder system can be divided into 2, which are wax-based binder system and catalytic-based binder system. Generally, the wax-based binder system will have a lower viscosity and mechanical strength compared to the catalytic-based binder system. Now, here are the challenges we face for powder injection molding. First, it struggles to form large part due to insufficient strength generated by the screw. Second, the molten feedstock must have sufficient and suitable viscosity in order to form the desired part. Third, the green part must have sufficient strength to resist deformation during transport. And fourth, all polymeric binder must be removed after sintering. And finally, in order to minimize shrinkage, the solid loading must be very high. Now, the objective for this project is to develop a new polymeric binder for transparent ceramic powder, and the solid loading must be 60% when it mixed with alumina powder. Now, this feedstock must have sufficient strength to resist deformation during transport, and it must have a good melt flow at 107° extruder temperature. The feedstock must be compatible with a wide mold temperature range, and it must have 0 residue binder after sintering. Now, the machines we will be using for this are for the processing, arbor injection molding machine, planetary mixer, twin screw extruder, debinding basin, and furnace. The characterization machine we'll be using here is forward bending tester, this one, and finally tensile tester. The initial material we choose here are stearic acid, polyoxymethyl, and other special polymers. Changes and replacement onto the materials and composition will be based on trial and error. Now, this is the aim of my presentation. Thank you.